आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़ की आवाज़।
विज्ञान की आवाज़ podcast is a STEM popularization initiative catalyzed and supported by the National Council for Science and Technology Communication, produced by Media for Community Foundation, content support by Kadalose FM 90.4 Community Radio, and hosted by yours Surya Kiran. Now, let's meet the scientist of the day, who works in the development of polymers and composite materials for medical devices with special emphasis on natural fiber reinforced materials. Dr. Jijo Raj, Scientist C, Sri Chitra Tirunal Institute for Medical Sciences and Technology, Thiruvananthapuram.
Hello, my name is Dr. Jijo Raj. I'm a scientist at Sri Chitra Tirunal Institute for Medical Sciences and Technology in Trivandrum in India. So my background is in polymer engineering. I did my BTech in polymer engineering from Mahatma Gandhi University in Kerala, and after I moved to University of South Brittany in France, where for doing my masters in polymers and composite materials, which is related to the eco design of the materials. And then I continued to do a PhD there in natural fiber reinforced bio composite materials. And from there I moved to Belgium to do my postdoctorate research, and there I was specialized in atomic force microscopy in order to understand the nanoscale organization of materials. And then I come back to France at the Atomic and Alternative Energy Commission in Grenoble, where I did research in conducting polymers for organic electronic devices. And later I moved to New York University in Abu Dhabi in United Arab Emirates, where I was working on asphaltene deposition on steel in order to mitigate asphaltene deposition problems in the oil industry. And from 2018, I have this wonderful opportunity, golden opportunity, to come back to India and work at the Sri Chitra Tirunal Institute in medical devices at area.
Sir, can you brief us about your research areas?
So my area of research is related to the development of polymers and composite materials for medical devices. So we develop new polymer formulations, keeping in mind the area, what is required. For example, there is for developing bone integration materials. We also developed natural fiber reinforced materials as new composite materials in order to address the sustainability and environmental friendliness of these materials, to reduce the waste of medical plastics. Those areas that we are currently working, and these are actually recently an industry sponsored project by Tata Steel. So we participate in their Material Next event in 2021, where it was a national level innovation challenge. So we participated and we were pre-finalists, but then Tata came back to us and told that we are interested in full funding your project. So we are currently working on short coir fiber reinforced polymeric material for orthotic assistive devices.
Interesting. Can you tell us the potential use of your research on a common man or the nation's field of science as whole?
So for common man, since environmental sustainability, environmental protection are very important, not only for the man but also for the whole population of the earth in general. So the medical plastic pollution is also a problem. So the common splints and orthotic assist devices mostly are made from non-degradable polymers. So our objective was to develop a new biodegradable polymer materials, but the bioplastics has less strength, and this is a big problem. And one way to overcome is to use natural fibers as reinforcement elements to improve the strength of these bioplastics. So while doing that, we are actually supporting the traditional natural fiber industry, which is a very big source of India actually, because when we say petroleum and oil is a resource for the Gulf nations, similarly India, these natural fiber are very important and very interesting properties they have, so they can be used for useful for purposes. For example, in composite materials. The inspiration for this is actually from my PhD degree in France, where they were using flax fiber. And flax fiber is, the linen, the fabric that we have. It's a very expensive material. But in France, they were using this linen in order to make composite materials. And right now, there is a company called VKAEP based in Switzerland. They are actually working on to develop these flax fiber reinforced materials as Formula 1 car seats. They are using it as satellite components, so that for the re-entry, these space debris is a problem. So while doing this re-entry, since we make with this natural fiber, it will completely burn. So it is more safe for the space. Also for the high speed, the crash and all, these natural fiber composites are more damage tolerant. It will not shatter and to small sharpened pieces like carbon fiber reinforced resins. So this is mainly due to the energy absorption property of this natural fiber. So in Kerala, there is we work on the coir fiber, which is a local natural resource from the coconut tree, and this is taken and we are using the as received coconut ropes, small ropes. So there are local traditional small scale industries, they are making these, so they are buying it, we are buying it, and we also developed an equipment where we can systematically make short coir fibers with a well-defined length, and these can be used to we used to make composites with a very good performance and very high strength. And recently Tata is also very interested in this technology, and they are sponsoring this research.
Fascinating. Can you please share us about the past, the present, and the future possibilities of your research areas?
Yeah, so the major challenge with these coir fibers or natural fibers, their inconsistency in their the texture, for example, the heterogeneities, moisture absorption. But nonetheless, we have developed some technologies where we can overcome these variations in the property due to some processing that we are doing. So before this, we were largely depending upon glass fiber reinforced composites, and glass fibers are while working with these glass fibers are hazardous for the body. For example, if you inhale this glass fiber, it can go to your lungs and it won't come back. We don't have such a health hazard issue with this natural fiber, and it is more safe, and it contributes to what they say environmental friendliness and biodegradation. And also while using these natural fibers is actually identified as one of the topmost emerging technologies in the World Economic Congress in Davos in Switzerland in 2019, and it was listed as the emerging technologies, and for contributing to a circular economy. So we are now targeting external orthosis materials, devices, for example splints, cast, etc. We are focusing on that. Another emerging application is positioning devices. For example, when you're doing MRI scans or CT scans, you have to position the patient. So, and that material have to have less X-ray attenuation. Recent research has shown that these natural fiber reinforced resins are having greater X-ray or less X-ray attenuation when compared to carbon fiber reinforced materials. So the X-ray attenuation property is much better for this. For this particular desired application. Why? Because India, if you see, is one of the world's largest natural resource country. We are so blessed with as the coconut fiber. These have amazing properties like energy absorption property. That is, you can absorb a lot of load, which is very unique for this fiber with no other fiber. And India is also the largest producer of jute. which is another natural fiber. Very, very interesting. So we have a lot of natural resources. So Westerns and European countries advance a lot in these applications of this natural fiber, composites and materials and technology. One factor that drives them was environmental sustainability, and in Europe it was only possible because a strong industrial backup for this, because an industry was there to lead the research, to drive to guide actually them of what they need and expected things, and evolve this research and set the targets and achieve it. We had that golden opportunity now with Tata Steel. They are funding this research, and it's very dynamic to work with them, and we have bi-weekly meetings to research updates, and we've made much big progress with them by working with associating with the industry. So future looks bright.
May we know the ranking of India in this particular area of research?
We still in this particular area of research on natural fibers based composite materials, much of the research has been focused in the laboratory scale. We need a big industry to come up. So I was mentioning that for example, this particular case of short fiber reinforced plastics, one of the major challenges is to consistently obtain these short fibers in an industrial scale. Then only it can be translated to an industrial productions and applications and coming to the market and be economically competitive. One of the challenge was that the processing of the machinery was not that much in order to make the short fibers, because if you see the literatures, in the scientific literatures, what they were doing is they're taking the fibers and manually cutting them with their hand, with the scissors, so that you can't assure the quality or consistency in the quality. But what we have developed is also a way where we have a modified pelletized equipment where you can directly feed the rope, and we can give the settings so that we have the final consistent product as an output fiber. So this we hope will be a big game changer. So a lot of industries will get attracted, and they can transform into the future. Yeah.
You're listening to Vigyan Ki Awaaz podcast, catalyzed and supported by the National Council for Science and Technology Communication, produced by Media for Community Foundation, content support by Kadalose FM 90.4 Community Radio, and hosted by yours, Surya Kiran. Let's get along with the episode and get to know our contemporaries in this research areas as shared by Dr. Jijo Raj.
In this natural fiber reinforced materials industry, Europe is leading. France, Switzerland, Germany, Belgium, they are key players, and then the Nordic countries, especially Sweden and Finland, are leading in their cellulose-based fibers, their products and usage. Yeah, and much research also is happening in Japan. But we believe that with the strong backup of government and industry, India too can lead, because we are the number one rich in natural fiber resource, and our fibers have very unique properties. For example, the coir fiber, it have saltwater resistance. So you can use these based materials and you don't have to worry about corrosion, unlike when you use metals. So for Navy and all, for a lot of applications, very high potential. So I dream of a day where we use a lot of these. We could use our natural resource to make technologically high-end products, and that can be useful for the nation.
Now, can you tell us how Indian industries are associating with this project?
Yeah, only with the support of the industry we can take to the next level. And we Tata Steel had this wonderful idea of Material Next event. They are organizing across India. We participated, and we were so lucky that they identified this potential and they funded this. And the material development phase 1 is completed, and now we are transitioning to the phase 2 part of this.
Interesting. Can we have a rundown on your patents, research papers, and the awards you have won?
So, during my career of up to now, I have published over 25 peer-reviewed international scientific papers. From Chitra, I have filed a design registration. We already completed. Then several patents and design registrations are ongoing in preparation. and several publications are also in process. I got a Program Coordinators Award since I joined the institute from DST, from the Indian Institute of Public Administration for Foundation Training Program. So there I got an award from New Delhi.
Thank you, Dr. Jijo Raj, for spending your time with us and sharing your research innovations. Conclusively, would you like to say anything on the Vigyan Ki Awaaz podcast as one of the STEM popularization initiative by the Department of Science and Technology, the Government of India?
Yeah, so I wholeheartedly thank the efforts of DST in popularizing science in India, and we hope this podcast program will be so much useful to the people of our country to know what scientists in DST institutions are doing, their recent research, and what this research will have or impact the lives of the people or improve their lives of the people and the environment. Thank you very much.
This was an enthralling episode. I'm sure you as listeners also felt the same amount of anticipation I felt throughout the episode. You're listening to Vigyan Ki Awaaz podcast, catalyzed and supported by the National Council for Science and Technology Communication, produced by Media for Community Foundation, content support by Kadalose FM 90.4 Community Radio, and hosted by your Surya Kiran. We will meet again in another exciting episode. Thank you for listening.